Okay, let's review something that we already know. You've actually already done problems like this, but I want to make sure we have good notes, so we're going to go ahead and work out some more and write them in our notes. Sometimes it's easier to take notes when you have an idea about what you're doing. So, we're going to do problem 1, and this is already set up for elimination, and you can tell because if I draw my lines, notice that the y's will cancel. And because positive 5y and negative 5y will become 0y, and 0y is nothing. So they're going to go away. And then we're going to get 8x equals 17 minus 9 is 8. So we're going to get 8x equals 8. So 8 times something equals 8. Well, that would be 1, or we could divide by 8 on both sides, and we're still going to get x is 1. So we know what x is. Now we're going to use that and plug it back in to one of the equations. So I'm going to look at the original equations again, and it does not matter which one we pick. I usually pick the one that has more positives, just so I don't make an error, but we could pick either of them. I'm going to pick the top one because it seems like the easiest one. So I'm going to write it over here, 2x plus 5y equals 17. And notice that x is 1, so I can either use the x or I can use a 1. And in this case, we need to use the 1 because we were trying to solve for y, and we can't ever solve for more than one variable at once. So we have to plug 1 in for x so that y is all by itself. So we have 2 plus 5y equals 17. And this is just a two-step equation. We're going to subtract 2. And then we get that 5y equals 15. Well, 5y means multiplication. So 5 times something equals 15. What times 5 would give me 15? Well, it would have to be 3. So y has to equal 3. So we're going to write that underneath here. So y equals 3. So x is 1 and y is 3. Just to be sure, just to check ourselves, let's graph it and let's make sure that we're right. Okay, if we're right, then these two equations will intersect at point 1, 3, because that's what we've concluded. So let's graph them and see what happens. So I graphed the two equations, and sure enough, they intersect at 1, 3. So that is their solution. So we know that we're right. So you can always check yourself either by graphing or by plugging the x and the y back into the equation in both of them. And if they both work out fine, then you know you're right. Okay, so let's go ahead and just work these out too. And you should go ahead and work them out and then play the video and see whether you got them right or wrong. If we add these two equations together, we're going to get 8x equals 16, which would mean that x is 2. So we know what one of them is already. Looking at these two equations, I think I'm going to pick the second one to plug back in. So I'm going to put 2 in for x. So I'm going to give myself some space. And I'm going to say 3 times 2 plus 6y equals 48. And of course that's 6 plus 6y equals 48. Subtract the 6, and I get that 6y equals 42. Well, I know that 6 times 7 equals 42, so y must be 7. But I'll show you the work. If I divide both sides by 6, 42 divided by 6 is 7. So I know my solution is 2, 7. So if you got 2, 7 for got it A, good job. Let's do B. If I add my columns, then the x's will go away, and I'll get negative 7y equals 14. If I divide both sides by negative 7 to get rid of it, then I'll get y equals negative 2. It's always easy to solve for the first one. The harder one is the second one, but it's still not that bad. So y equals negative 2. Let's look at the equations and see which one we should pick. Let's pick the second one. It looks like it's going to be the easier one. But if you chose the first one, that's fine. You should still get the same answer. So y equals negative 2. And I get 3x. Negative 4 times negative 2 is positive 8. And then I'm going to subtract 8. And I'll get 3x equals negative 3. And 3x equals negative 3. Divide by 3. And I get that x is negative 1. And y was negative 2. Well, I'll rewrite that. Negative 1, comma, negative 2. So if you got negative 1, negative 2, or got it B, good job. Now it's time to move to something harder. If I look at these equations, notice that I have a 7 and a negative 2. And I have a 5 and a 15. Neither of those are in good shape, meaning I can't just make one a negative and they're going to eliminate. I'm going to have to multiply by something more than negative 1. So I'm going to make my decision. I think the easiest one, I'm going to rewrite this. You have to be good at your multiplication facts for this to become very easy. If you're not good at your multiplication facts, it'll be harder, but it won't be impossible. Notice that 2 and 7, I can't multiply 2 by anything to get to 7. But I can multiply 5 by something to get to 15. And so that's the one I'm going to pick. I could multiply by 3. If I multiply everything here by 3, I'll get negative 15y, which is good because that's exactly what I need. So we're going to multiply the second equation by 3. Not by negative 3, because it's already a negative. Okay, I needed it to be negative, so the way it is now is good. But I need it to be negative 15, not negative 5. So when I multiply, I'm going to get 21x minus 15y equals 51. Or 51. Okay, so now the equations that I have are good. I'm going to erase this middle one because we multiplied that middle one by 3, so we don't really have that equation anymore. We have a new equation that's already been multiplied by 3. Now notice if I add, the 15s will cancel, which is what I wanted. So these 15y's will go to nothing, and I'll get new numbers. I'm definitely going to run out of room, but we should be able to write what we're going to get. 21 minus 2 is 19. And that's going to equal 19. So our equation is 19x equals 19. So x is definitely going to equal 1, but we'll show our work. So right now we're at 19x equals 19. And then we're going to divide by 19 on both sides, and we get that x is 1. So we know what one of them is, which is good. Okay, it's always good to know what one of the variables is. Now we're going to decide on which of the original equations are we going to plug x back in for. I think the second one actually looks easier. So if we, instead of writing an x, if we write a 1, then we can solve, and let's make sure it was x equals 1. Yep. Okay, so x equaled 1, and we're going to get 7 minus 5y equals 17. Notice a lot of kids will say that 7's being subtracted, but what's the sign in front of the 7? And a lot of kids would say, well, there's no sign in front of the 7. And I'd say, what does that mean then? And they'd say, that means it's positive, and they'd be right. Okay, so this is a positive 7 at right now. It's already a positive 7. So the only way to get rid of a positive 7 is to subtract 7. So these will go away, and we'll be left with negative 5y here equals 10. And that's very hard to see. So right now we have negative 5y equals 10. And again, I hope you're really good at one-step equations, because you are much higher right now than one-step equations. And so if you're not good at them, this is going to be very hard. But y equals negative 2. So x was 1 and y is negative 2. So 1 comma negative 2. That's our solution. Okay, the last example that we're going to look at before we start our assignment is, what if it's really, like, what if you have to multiply both equations by something, which is possible. So let's look at these two equations. Can I multiply 3 by anything to get to 4? No. Can I multiply 2 by anything to get to 3? No. So it's not as simple as the other one. You know, if you remember the other one, we just had to multiply 5 by 3 to get to 15. So that wasn't that bad. But this one, you know, we're going to have to make a choice. Either we're going to have to go make it 12x and negative 12x, or we're going to have to go to 6y and negative 6y. Notice our choices here. The least common multiple of 3 and 4 is 12. The least common multiple of 2 and 3 is 6. That's the first number that they both share. So watch how I got there. I did 3, 6, 9, 12, 15. Okay? 4, 8, 12, 16, 20. Notice the first number they share is 12. That's why I chose 12, because that's the easiest choice. Okay? In the same concept, you know, 2 and 3, if I were going to 2, 4, 6, 8, and then 3, 6, 9, 12, notice 6 is their first multiple. So we always try to make it easier on ourselves. You know, we don't want to do more work than we have to. So it's really our choice. Do we want to go to 12x or do we want to go to 6y? And it doesn't matter which one we choose. I think I'm going to go with, let's go with 12x. It doesn't really matter. So let's write each equation. 3x plus 2y equals 1. And what I want to have happen is I want to get to 12x. So that would mean I'd have to multiply by 4. And if I multiply the x's by 4, I have to multiply everything by 4. So that's exactly what I'm going to do. So I'm going to multiply everything here by 4. And now my new equation is 12x plus 8y equals 4. So I'm going to write that above here. Actually, I'll write it on another sheet of paper. Okay, then in the second equation, I need to go from 4x plus 3y equals negative 2. And I need to make this one negative 12 because I need a positive 12x and I need a negative 12x, or else they're not going to eliminate. So what I really need is for the 4x to go to negative 12x. Well, the only way I could do that is if I multiplied by negative 3. So not only do I multiply the x by negative 3, I multiply everything here by negative 3. So my new equation, well 3y times negative 3 is negative 9y, and negative 2 times negative 3 is positive 6. So take this in. I mean, it's a lot to take in. You know, we have changed both equations now. But we're allowed to do that, because as long as we multiply both sides of the equation and everything on both sides of the equation by the same number, then we really haven't changed anything at all. So I'm going to rewrite this one below the other one, and I'll put it in red. It was negative 9y equals 6. Okay, so now we have our new problem, and I'm going to draw my lines. Now notice I got 12x and I have negative 12x, which is great because they're going to eliminate. And I have an 8y and a negative y, and that's going to be a negative 1y. You can check it on your calculator. Negative 1y equals 4 plus 6 is 10. And then if I divide by negative 1, I get that y equals negative 10. So let's write that over here. So we do have one of them solved for. Y equals negative 10. Okay, so it's a lot more work. Notice how previously we got to the first solution very quickly, and this one took a lot longer, but it's not that bad. You just have to think ahead, and you have to make a plan. Like I plan to make a positive 12x and a negative 12x, and what do I have to do to make that happen? We could have chosen a positive 6y and a negative 6y, and that would have been fine too. So we have y equals negative 10. So coming back to the original equations, which one do you want to pick? Let's look. Y equals negative 10. Let's just pick the first one. It looks pretty easy. So we have 3x plus 2y equals 1. And what we know is that y equals negative 10, right? Yeah, negative 10. So I got negative 10 here. So I have 3x minus 20 equals 1. And if I add 20 to both sides, these 20s will go away, and I'll get 3x equals 21. Well, 3 times 7 is 21, so x must be 7. But let's work it out and show our work here. 3x equals 21, and we divide by 3, and sure enough, x equals 7. So x is 7, and y is negative 10. A lot to take in here. There's a lot to take in. I'm going to make a second video, and we're going to work out some examples from one of the assignments. Actually, we might make 2 more videos and work out assignments from examples from 2 separate assignments.